Right, we'll move to the next question. Question number 12 is what x cube minus 1 whole power of 1 by 3 into x power of 5. It is x power of 5. So here you have x cube minus of 1 to the power of 1 by 3 into x power of 5. If we try to observe over here, this expression that you have, it is x power of 5 you have. We'll try to rewrite this expression in the form of, because you have to take any one value to be equals to t, right? One should be the differentiation of the other. Suppose if I am taking x power of 5 and try to differentiate x power of 5, d by dx of x power of 5. If I try to differentiate, I'll be getting the value as 5x power of 4. So this x power of 4 should be here. You don't have, right? I cannot take x power of 5 to be equals to t. You also have x cube there. D by dx of x cube you have. Now if I try to differentiate this one, so its derivative will be what? 3x square, right? But one thing we can do, we can express this x power of 5 in terms of this x square, x cube minus 1 whole power of 1 by 3. Because I require x cube, I'll write x cube. Can I write this x power of 5 as x power of 3 into x power of 2? This 3 plus 2 will be what? 5. Are you getting this one? So how will you get an idea that you have to get or express this x power of 5 as x cube into x square is that? Just by differentiating, because one should be the derivative of the other. No, I have shown you in the previous class. If you have a function, integral of the given function, f of x, its derivative should be present, either in the numerator or in the denominator. So using this rule, we'll try to differentiate whatever I have. I have only these two values, x power of 5 and x cube. I just differentiated it. This is not at all possible. So the possibility is that you have to get x square. So how to get x square? How can we express? The only way is just expressing this x power of 5 as x cube into x square, so that you can get that x square value here. This value to be equals to t. So let us try to integrate this one. So let us take this as integral I to be equals to integral of, this is x cube minus of 1 to the power of what? To the power of 1 by 3 into, we have the value as x cube into x square into what you have into dx, right?
Yes.
Now let us put the value of x cube to be equals to how much? X cube to be equals to t, right? So if you put the value of x cube to be t and then try to differentiate this one, so differentiate this expression, x cube differentiation will be 3x square is equals to, differentiation of t will be dt by dx, right? What you require over here is you require square into dx, right? So dx on the other side and 3 on the other side. So therefore we'll be getting x square and cross multiplying that dx is equals to this dt, cross multiplied that 3 on the other side becomes divided by 3. Now put this value back there, all right? So if you put the value back over here in the given expression, you will be getting the value of I to be equals to, that is integral of x cube. X cube value is t. T minus of 1. It is whole power of how much? It is whole power of 1 by 3. Into what we have? Into this x cube value. What is x cube value over here? X cube is nothing but t. X cube is t. What about x square into dx value? Dt by 3. It is dt by 3, right? However, this 1 by 3 which is there is a constant, right? 1 by 3 is a constant. I'll take that 1 by 3 outside. 1 by 3 is outside. It is integral of what you have. It is t minus of 1 It is t minus of 1 whole power of 1 by 3 I have, right? Into, it is t into dt. Getting it? Even then, we cannot integrate this one. Can you see over here? T minus of 1 into t into dt. Can we integrate this one? Because one is not the derivative of the other over here. You are having t minus of 1. Here you are having t. So what we can do is either express this t minus 1 as t or express t as t minus of 1. So two possibilities you have. So I'll keep, because this power is 1 by 3, I cannot change this one. So I'll keep this t minus 1 to the power of 1 by 3 as it is. And then try to express this t in the form of, can I write t, because I have to get this as minus of 1. I'll put that as minus of 1, right? So if I put that as minus of 1, can I just subtract without any reason? No. Because I'm subtracting this value, I need to add this value. Subtract and add 1, right? Times of what we'll be getting? Times of, we'll be getting the value as dt. Times of dt. So what you have done over here is we have just add and subtract 1. Add and subtract 1. Getting it? Like adding 1 and subtracting 1. When we have to do, this has to be done only when you have the power of this t or x, whatever it is. Here you can see the power over here. However, this is the whole power, but only for t. In this case, the power is 1. Here also the power is 1. Whenever you have this type of same power, then try to get one value similar to the other value. That is what we are doing, because t minus 1 you have. So I'm trying to get the same value t minus of 1 over here. So that is how we'll get an idea that I have to get that value. Now further, you try to simplify this one. This will be equals to 1 by 3 into integral of. So it is t minus of 1 to the power of, what will be getting? 1 by 3. So now I'll try to group this one. I'll group this t minus of 1 separate, because I want to get the t minus 1, no? Plus this 1, I'll keep it separate. Times of what you have? Times of dt. Or further we try to simplify, it is 1 by 3. It is integral of. Now let us multiply this one. T minus 1 with this t minus of 1. So when you multiply, you'll be getting t minus of 1. Basis is the same. What is the power over here? It is 1 by 3. What is the power over here? Power is 1. 1 by 3 plus 1 plus, again you multiply this t minus 1 to the power of 1 by 3 with this 1. So you'll just be getting again t minus 1 to the power of 1 by 3. Since we have two terms over here, so let us try to apply the integral separately for each of the terms. So it is 1 by 3. I am applying the integral for the first term. The first term, that is integral of, it is t minus of 1 to the power of 1 by 3 plus 1 will be how much? Into, you multiply this dt inside, one integral. This first integral is separate, plus, again for the, go for the second integral. This integral of t minus of 1 whole power of just 1 by 3 times of dt. So close the bracket. Now I need to integrate, no, this one. Now the question is how to integrate. We have this formula. We have to use the same formula. Integral of x power of n into dx will be equals to x power of n plus the constant of integration c. But this is not just x power, no, it is having t minus of 1. You have this formula. In general, write down this form: ax plus b whole power of n into dx. A generalized formula I am giving you. Whenever you have this type of expression, ax plus b whole power of n into dx, in that case, you have to keep. So this will be treated as the same x itself. So this expression to the power of n plus 1. So you here you'll be getting ax plus b to the power of n plus 1 by n plus 1. Right? Similar to this one. But we need to just differentiate this value. Ax plus b derivative will be a. So I'll write down that in the denominator. Are you getting this one? Plus the constant of integration c. So I'll use this one over here and try to integrate this one. This 1 by 3. So it is t minus of 1. So we'll be getting t minus of 1 to the power of n plus 1. That is 4 by 3 plus 1. 4 by 3 plus 1 divided by 4 by 3 plus 1. X power of n plus 1 by x power of n plus 1. But now if I try to differentiate this one, derivative of t with respect to t, what will be its value? Just 1. Our coefficient of t is what? 1. I've written a over here, I'll just be writing 1 over here. Plus. Similarly over here, it's t minus of 1 you have. So t minus of 1 to the power of. Again, 1 by 3 is there, so we'll be getting 1 by 3 plus 1 divided by how much? 1 by 3 plus 1. But what is the coefficient of t here? 1. So 1 times you can write. Plus the constant of integration c. Or further, let us try to simplify this one. We will be getting the value as 1 by 3. It is t minus of 1 whole power of 4 by 3 plus 1 will be 7 by 3, right? Whole divided by again 7 by 3. Plus it is t minus of 1 whole power of how much? 1 by 3 plus 1 will be 4 by 3. Whole divided by 1 by 3 plus 1 will be 4 by 3. Plus the constant of integration c, which will be equals to 1 by 3. 7 by 3, if I take in the numerator, it becomes 3 by 7 times of. Now, since integration is complete, you can put back the value of t. What is the value of t we have taken? X cube, no? So here you can see x cube we have taken. This one, x cube. So let us put that value back. X cube minus of 1 whole power of 7 by 3. Plus here again 4 by 3 can be written as 3 by 4. Again the value of t is x cube. So it is x cube minus of 1 whole power of 4 by 3 plus the constant of integration c. But however, if you try to observe over here, do you have 3 common here? 3 is common. You can just take 3 outside. So this 3 and 3 will cancel out. We'll just be getting 1 by 7 x cube minus of 1 whole power of 7 by 3 plus 3 by 4 into x cube minus of 1 whole power of 4 by 3 plus the constant of integration c. But however, you can see this 3 and 3 will get cancelled. Now you can write down this entire expression without 3 plus the constant of integration c. So this will be as it is 1 by 7 x cube minus of 1 whole power of 7 by 3 plus 3 by 4 into x cube minus of 1 whole power of 4 by 3. That will be the final answer. Are you getting it? Any questions, any doubts here? Or the problem is lengthy because the given expression is not in the form of f of x into f dash of x. If it is in the form of f of x into f dash of x, directly we can do it. But here you need to just think. If you get the first step right, no? If you get this first step, this idea, if you get, the problem is solved. But the reason why students will feel difficult is they don't get an idea how to x power of 5 as so much. That is the reason why we have to do this step. The moment we do this step, you get an idea. The initial step is very important for this problem. This is a very crucial step. Most of the students will fail here only because they'll not get an idea on how to express x power of 5 as x cube into x square. But suppose if I give this problem in this form like x cube minus of 1 whole power of 1 by 3 into, suppose if I give that as x square itself. In that case, you can very easily put x cube as t and then solve the problem. This problem is very, very easy directly. But the moment you get some other power, it will be difficult for you. So now, the moment you try to see this expression over here, the denominator differentiation, you try to differentiate this expression, the denominator differentiation. Are you getting the numerator? Because x cube differentiation is what? X cube differentiation will be 3x square. So can you see that 3x square value there? The moment you try to see that one, it is in the form of what? It is in the form of f dash of x by f of x form. It is in this form. f dash of x by f of x. Now it is having some power there, whatever the power it is, doesn't matter. So it is in this form. Its derivative is present in the numerator. So whenever its derivative is present in the numerator, very easily you can differentiate the expression. Right? Let us try to differentiate this one. So first we'll try to put the integral value over here. It is integral of. So I'm putting the integral. It's integral of x square by 2 plus 3 x cube to the power of 3 into what? Into dx. So I'm taking that integral as I. So therefore, put the value of 2 plus 3x cube to be equals to t. We'll just try to differentiate this one. So derivative of 2 will be 0. What will be 3x cube differentiation? 9x square, right? Is equals to derivative of t will be dt by dx. What I want is only x square into dx, right? So cross multiply this dx on the other side and 9 on this side. So x square into dx will be equals to dt by 9. Now just try to put this value of t as well as this value back in the given integral. So I'll be getting the integral as I is equals to integral of how much? It is dt by 9. dt by 9 whole divided by this value is nothing but t. So we'll be getting t cube. Or further, if you try to simplify this one, 1 by 9 is constant outside. T cube you can take in the numerator. If I take in the numerator, it becomes minus of 3 into dt. So let's try to integrate this one. So what will be its integral value? Plus 1 divided by minus 3 plus 1 plus the constant of integration 1 by 9, it is t power of minus 2 by minus 2 plus the constant c. Or if you try to further simplify this one, this will be equals to minus sign I'll write outside. Just multiply this one, you'll be getting so much. It is 1 by. Can I get this value in the denominator? Because negative power is there. Make it as positive power as t square. Let's see. Now we can just substitute the value of t. T that we have taken is 2 plus 3x cube. Just plug in that value. Minus 1 by 18. 1 by 2 plus 3x cube whole power of 2 you have over here whole square plus the constant of integration c. That will be the required solution. 1 by x into log of x to the power of m, where x is greater than 0 and m is not equals to 1. Right? M is not equals to 1. So let us write down this integral. Let I is equals to, it is integral of 1 by x times of log of x to the power of m into dx. Now the question is, which is the differentiation of the other? Yeah, log, if you try to differentiate, we'll be getting the value as how much? Because we know this expression, no? Should always try to see which value when you differentiate, you'll be getting the other expression. So log of x will be what? 1 by x. So whichever you try to differentiate, if you're getting the other value, this value itself, you have to take it as t. So put the value of log of x to be equals to how much? To be equals to t, right? Most of the time, one more clue you can see, most of the time, you can just check it. Whichever is having power, no? In most of the problems that we are doing, whichever is having power, we are taking that as t. In this power m is there, we are taking as t. It's not always the case, but most of the time. You can see here also. But that is not the clue, because here also you are having power. But the terms that are there, no, it is having power. In this case also you try to see. Here also can you see that power is there. There is another clue for you. In that power, any one of the expression has to be taken as t. But this is the standard procedure that you need to follow. If you differentiate the value which is there that you get. So this particular value you have to take it as t. Right? Okay, now let us try to differentiate this one. We'll try to differentiate. Log derivative will be how much? It is 1 by x. That is equals differentiation of t with respect to x will be dt by dx. But you want this value to be 1 by x into dx, no? Cross multiply. 1 by x into dx will be equals to what? Dt. So just plug in this value back there in I is equals to, you get the value as integral of 1 by log x. Log x is t, we'll be getting t power of m. And you have this 1 by x dx. 1 by x dx. Its value is what? Its value is dt. Or further, if you try to simplify this one, you'll be getting the expression as integral of t power of this plus m. When it goes in the numerator, becomes minus of m times of what? Times of dt. Now you can go for the standard procedure. Integration of x power of m will be x power of m plus 1, n plus 1 plus n plus minus m plus 1 divided by minus m plus 1, then plus constant of integration c. Or you can rewrite this value to be equals to, what is the value of t we have taken? T value we have taken it as, so you can write it as log x over here. Log x to the power of what? To the power of minus m plus 1. Or I can even write it as 1 minus m. First positive, then negative. Divided by, here also I can write the same thing, 1 minus of m plus the constant of integration c. This is one way of writing the solution. Now, why in the question the log was in the denominator, so I want to express that also in denominator. There is other way of expressing it, but that becomes a bit complicated. So expressing this expression which is there, no, you have to express this as t power of. You have to take you have to take minus common and write down that as m, and because plus 1 is there, it becomes minus of 1 whole divided by. So here, as it is, you can write it is 1 minus of m, 1 minus of m plus the constant of integration c, plus constant of integration c. So, or further, if you try to write t value is what? T value is log of x. T value is what? T value is log of x. So it is log of x to the power of minus of m minus of 1 whole divided by this 1 minus of m plus the constant of integration c. Now, because the power is negative, to make the power as positive, you can write in the denominator 1 by 1 minus of m into what you have. It is log of x to the power of, because negative value is there, when it comes in the denominator, it becomes positive, m minus of 1 plus the constant of integration c. This is the other way, but I don't prefer this one. But I'll solve the problem in case prove that result is given, then you should be able to do it. But you can express this way. This becomes rather easier, no? Only one step, you'll get it. Next question is, which is that one? X by, I'll just tell you how to do it. 4x square. Differentiation of x square is what? 2x, right? Over the 2 you can multiply. But what you can do is, you can take the entire expression to be what? Our others are constant, no? This will become 0. This, however, will be constant. So can you take this value to be equals to t? Simplify it. Can you try it? It's very simple. So I'll leave this as a homework for you. You can just try it. So we'll move on to the next question. It is e power of 2x plus 3. So let us take this as, let I is equals to, it is integral of e power of 2x plus 3 times of dx. Always remember, whenever you have e power exponential, most of the time, the power value which is there, that itself has to be taken as t. So therefore here we'll put the value of 2x plus 3 to be equals to 2x plus 3 to be equals to t. Let's try to differentiate this one. It is 2 into differentiation of x will be 1 plus the constant 3 will be 0, and differentiation of t with respect to x will be dt by dx, right? Or it's 2 times of 1 will be 2, or I do, you have one. Let me write one more step. 2 is equals to dt by dx. But here, what do you see? You have only dx. So just cross multiply dx on this side, and can write this as dt Cross multiply this 2 divided by 2. Now in place of this dx, you can put it as dt by 2. Just plug in back there. So therefore, you get the integral I is equals to, it is integral of e power of 2x plus 3 is what? T. What is dx value? What is constant here? 1 by 2 you can take outside. You'll be getting integral of e power of t into dt. That is 1 by 2. What is integral of e power of t? You know the standard formula. Or if it is in this form, you'll be getting e power of ax divided by coefficient of x is a plus c. Right? So it is e power of t. Differentiation of e power of t will be e power of t itself. So e power of t plus the constant of integration c. Or you can write 1 by 2 e power of. What is t you have taken? 2x plus 3 plus the constant c. Very simple example. Next one, you have x by e power of x square. So it should be t over here because it is e power. So power value of e can be taken as a t value. Therefore, put the value of x square. Put x square to be equals to how much? X square to be t. You have to differentiate this one. Try to differentiate this. X square differentiation will be 2x. Differentiation of t with respect to x will be dt by dx. What I require is only x dx. So you can cross multiply this 2 on this side and dx goes on the other side. X into dx will be equals to dt. Cross multiply that 2, it is divided by 2. Now since you have x dx, you can just plug in that value there, dt by 2 there. So therefore you'll be getting I is equals to, it is integral of dt by 2 you get whole divided by how much? E power of x square value will be t. Or further 1 by 2, which is a constant outside, is the integral of, because e power of t is in the denominator, I'll take that in the numerator. E power of minus of t into dt. Let us try to integrate it. It's 1 by t. Just now I've given the formula, we have to go for the second formula. So here integration of e power of minus t will be e power of minus of t divided by coefficient of t is minus 1. The constant of integration c. Or you can just multiply this minus over here, we're getting minus 1 by 2 e power of minus t value I have taken it as x square, right? So it becomes minus half e power of minus of x square plus the constant c. That will be the required solution. We'll just move on to the next one. E power of tan inverse of x by 1 plus x square. So e power value which is there, that has to be taken as your t, tan inverse. So let us take the integral I to be equals to, it is integral of e power of tan inverse of x divided by 1 plus x square into dx. So therefore, we'll try to put tan inverse of x to be equals to t. So let's try to differentiate. So what will be the differentiation of tan inverse of x? 1 by 1 plus x square. So here itself we can see that value. So 1 by 1 plus x square is equals to what? Is equals to dt by dx. Now I want 1 by 1 plus x square into dx. So cross multiply the dx. You'll be getting 1 by 1 plus x square. Multiply the dx. Will be getting is equals to dt. So let us put this value back there in the given integral. You'll be getting I is equals to, it is integral of, it is e power of tan inverse of x is t. Then you have 1 by 1 plus x square into dx, its value is dt. The integral of e power of t will be e power of t, constant of integration c. But what is the value of t we have taken? Tan inverse of x. So you'll just be getting e power of tan inverse of x plus the constant of integration c. That is a required solution. The next question, e power of 2x minus of 1 divided by e power of 2x plus 1. But again, if you try to observe here directly, do you have the differentiation? Suppose if I try to differentiate the denominator, will you get the numerator? Or if you differentiate the numerator, will you get the denominator? We have to just check it. So because it is not possible directly to get it, then some substitution or some modification has to be done over here. What is the modification? You just try to check it over here. Suppose if I try to take d by dx of the denominator, that is e power of 2x plus 1, can we get the numerator? Or d by dx of e power of 2x minus of 1, if I try to differentiate, will I get the denominator? That's the question. It is not possible, right? The question is how to get this one. That's the major problem you have. So again, this is a problem similar to the problem that we have done here earlier, which was that question number first example that we did today here, right? It is similar to this one. You have to just think before you write this one, because you have x power of 5. There was a confusion. What has to be done? It is similar to that one over here. You have e power of 2x minus of 1, right? E power of 2x minus 1 divided by e power of 2x plus 1. The only possibility is that if you want to differentiate this one, you have to get the similar terms in both the cases, because you have one over here, its derivative, it's not possible, right? So now the question is, if you can get e power of x in both the expressions, in the first term as well as in the second term, then in that case, you'll be able to get the expression. Try to see how to get that one. Suppose if I say divide the expression, suppose if I am able to get the value as e power of x or minus e power of minus of x, or if I am able to get this value as e power of x plus e power of minus of x, because there is a negative sign, therefore you should be able to, can you get in this form or not? We have to check it. So the only way that you can make this e power of 2x as e power of x is dividing by e power of x. So one way of solving is that you have to divide numerator and denominator by e power of x. Will you get this idea just by seeing the question? But if you are solving it for the first time, how will you get an idea? So just by practice, if you practice more, you just get an idea. Similar problem, because next problem is also similar to that one. We'll try to see what is the difference between that problem and this problem, because question number 19 and 20 are almost similar, but this problem is slightly different from that particular problem. So how will you get an idea? We'll try, just solve this problem, and at the end I'll tell you how will you get an idea, because you should keep the answer in your mind. Only then you'll be able to get this idea. E power of 2x, right? Divide this term by e power of x. The whole of the numerator is divided by e power of x, right? Whole divided by, again you have e power of 2x. Each of the term is divided by e power of x. Getting it? So now if you try to rewrite this one, so what happens? It is e power of 2x is there. E power of x, if I take in the numerator, becomes e power of minus x. Can I write in this way? Minus. Here also, 1 by e power of x. E power of x, if I take in the numerator, can I write in this way? Whole divided by. Here also, we have e power of 2x. I'll take this value in the numerator, becomes e power of minus of x. Again plus. I'll take this value in the numerator, becomes e power of minus of x. Or further, this is, whenever the bases are the same, powers can just be added, right? So it becomes e power of 2x minus of x plus e power of minus of x. Whole divided by what you have is e power of 2x minus of x of minus of x. Just going on simplifying it. Or further, this can be written as e power of 2x minus x will be x plus, it is e, sorry, it was minus, this is minus. Numerator is minus, denominator is plus. So this is minus. Whole and whole divided by, how much you get? E power of 2x minus x will be x plus, it is e power of minus of x. So I've reduced the given problem in this form. Now if you try to integrate it, let the integral, but now we have reduced it into the form of e power of x minus e power of minus of x divided by e power of x plus e power of minus of x into dx. Now we'll try to check which is the differentiation of the other. Suppose you want to write down it is d by dx of. Let us check the denominator. It is e power of x plus e power of minus of x. If I differentiate this one, will I get the numerator or not? So first is d by dx of e power of x. Then again, the second one is d by dx of e power of minus of x. Now if I try to differentiate this one, differentiation of e power of x. Here, differentiation of e power of minus of x will be e power of, and differentiation of minus of x minus 1. Therefore, we'll get e power of x, e power of minus of in the numerator here.
Yes, sir.
So just by dividing with e power of x, we have brought in this form. You always remember, whenever you have an exponential function of this form, no, or the
Yes, sir.
original form which is there, original form, one is negative, one is positive, right? Whether it is numerator or denominator, whatever it is. If one is positive, one is negative, you have to check in both the terms, you have to get e power only. If this is plus 2x, it should be minus 2x. If it is x, it should be minus x. In that form, it should be, right? If it is in that form, then you can say that one will be the derivative of the other. That is what we are getting over here. So keeping this in mind, you have to solve this problem. So you should know what is the solution you have to get. This step should be there in your mind, only then you'll get an idea. If you don't have this step, you'll not be able to get it. So that comes with practice. Because if you already solved this one, you'll get an idea. If you're solving it for the first time, it is difficult to get this idea. So now since you have solved it, now whenever you get this type of problem, you should always keep in mind that you have to get in both the terms e power. Only then this will be integrable. So now which value can be taken as t? Yes, e power of x plus e power of minus of x will be equals to t. So let us try to differentiate this one. So try to differentiate derivative of e power of x. We have already done it over here. So e power of x will be e power of x plus e power of minus of x. In differentiation of minus of x will be minus 1. Derivative of t with respect to x will be dt by dx. Or you can just cross multiply that dx on the other side becomes e power of x. Plus into minus is minus e power of minus of x. I am cross multiplying that dx is equals to dt. So now you can put this value back over here in the given integral. So in this integral, you can put it. So therefore, you'll be getting I is equals to, it is integral of. So this value becomes what? dt divided by, this value will become t. So it is integral of dt by t. What will be its integral? Yes, dx by x form, no? Log of mod x plus c. So therefore, we'll be getting log of mod t plus the constant of integration c. But what is the value of t that we have taken? It is e power of x plus e power of minus of x plus the constant of integrations. That will be the required solution. Let us move on to the next question. I just give the clue. I'll not be solving it completely. I'll just tell you how to remove that clue. The remaining part you can do it, right? So let us take the integral. Let I is equals to, it is integral of, it is e power of 2x minus e power of minus of 2x divided by e power of 2x plus e power of minus 2x into dx. So let us put the value of the denominator e power of 2x plus e power of minus of 2x is equals to t. As I told you, whenever you have e power in this plus and minus, one should be plus, one should be minus. One should be plus, one should be minus. In that case, we can solve this problem just by putting this value as t and then proceed it. Now let us try to differentiate this one. So derivative of e power of 2x will be e power of 2x into differentiation of 2x will be 2 plus differentiation of e power of minus 2x will be e power of minus of 2x minus 2x differentiation will be minus 2. Then differentiation of t with respect to x will be dt by dx. Now What is common here? 2 is common. So if I take 2 common outside, we'll be left out with e power of 2x. This is plus into minus will be minus e power of minus of 2x is equals to what? Dt by dx. But you don't have 2 in the numerator, no? So if you want, you can just cross multiply that one. It becomes e power of 2x minus e power of minus of 2x. Take the dx on this side. That will be equals to dt by 2. Can you see that 2 has become a constant, has come outside? Okay, fine. So this, I'll leave it as a homework for you. We'll move on to the next question. What we have, tan square 2x plus 3, no? Tan square 2x 3 is minus 3. So tan square of, you're having this value. So what you have to do is you have to take this value to be equals to t. That's the only way you have. So let us take the integral. I is equals to, you have integral of tan square of 2x minus of 3 times of what? Times of dx. Suppose if you are taking 2x minus 3 to be what? To be equals to t, then its derivative should be present, no? Derivative of x is what? Derivative of x will be 1 minus the constant will be 0. Whenever you get a constant, you need not bother, right? You can take this value to be what? T. Constant, somehow you can adjust. So now you can put this value, put that is 2x minus of 3 to be equals to t. Let us try to differentiate this one. So 2 into differentiation of x will be 1 minus the constant will be 0 is equals to dt by dx. dt by dx. Here what is left out? Only 2 is there. Is equals to, you have dt by dx. But 2 I don't require here because I just cross multiply this 2 and dx on the other side becomes dx is equals to, it is dt by 2. Right? See, whenever you have constant, somehow it comes over here. So you need not bother whenever you're getting the derivative of any of the value to be 2. But suppose we are getting 2x square here, and if you're getting that as 4x, then in that case we should have x there. Now let us try to plug in there. You'll be getting I is equals to, it is integral of tan square 2x minus of 3. This value is your t, into dx value is what? Dx value is dt by 2. And if you try to simplify this one, 1 by 2 is a constant. You can remove that constant outside. 1 by 2, it is integral of tan square of t into dt. And the question is, can we express tan square in some other form? Yeah, you can express. Always, whenever you have secant square, that is the best way you can integrate it. So tan square can be written as secant square of t minus of 1 times of what? Times of dt. So whenever you don't have standard integral form, you try to search for an expression where you have its integral. Tan square integral is not there, then you have to search for another trigonometric function which has integral. So I have expressed this tan square in the form of secant square t minus 1. Now let us try to integrate this. It is half times of, so apply the integral for the first term. Integral of, it is secant square of t, multiply the dt, minus, again you apply the integral for the second term, integral of 1 times of dt. Now you can integrate. What is the integral of secant square t? Tan t over here. Minus integral of dt will be what? T. Integral of dt will be t. Plus the constant of integration c. But what is the value of t that we have over here? 2x minus of 3. Tan of 2x minus of 3. Minus. T value is nothing but 2x minus of 3. Plus the constant of integration c. That will be the required solution. Next question. Directly this step here is given. In the next problem, directly has given this step. What is the substitution there? 7 minus 4x has to be taken as t. So you take 7 minus 4x to be t and then simplify it. Again, secant square integration will get you tan. Only one, because when you try to differentiate here, no, it becomes minus 4 x differentiation. However, this will be 0, no? is equals to dt by dx. If you cross multiply, it becomes dx is equals to dt by minus 4. This minus 4 you have to include, no? Even if you're doing directly, you have to include that minus 4. Most of the students try to do directly and they miss out this minus 4. But if this is a CET question, then you can do it directly. Keeping in mind, always you have to keep that whatever this value which is there attached with the x value will always come in the denominator. There is a shortcut method that you have to learn. If you're doing this in the CET, you'll come to know. Because the term which is attached with x over here, no, the constant, that will come in the denominator. If you keep this in mind, you'll not do mistake. Then another problem is similar to which problem we have done, 18th one. 22 as a homework. 23 also, can I give it as homework? See here, sine inverse of x is what? T. You have to put sine inverse of x. You have to put sine inverse of x to be t.